Hello and welcome to our first lesson in Chapter 9, 9.1 here, identifying quadratic functions. By the end of the lesson, you should be able to say that you can identify quadratic functions from equations, tables, and graphs. Also, from a graph, and these are three representations, equations, tables, and graphs. We will have word problems come up a fair amount in this chapter. From a graph, determine and identify a parabola's maximum or minimum. And then finally, should be able to find the domain and range of a parabola. So some vocabulary we need to get familiar with. A quadratic function is any function that can be written in the form y equals ax squared plus bx plus c, where a cannot equal 0. And also the highest exponent of x has to be 2. So we have to have this number in front of x squared make the x squared show up. If it was a 0, we wouldn't even see it. B and c can be anything, but we want to make sure that the x squared shows up and its highest exponent is a 2. A parabola is going to be the u, or upside down u, shaped graph of a quadratic function. And then on a parabola, we'll see something called the vertex, the highest or lowest point of the parabola. It's where the max or min occurs. The y value will be the max or min. Also, the point over which the parabola is symmetric. So if you drew a vertical line, the axis of symmetry right through the middle, you'd see a mirror image of each side. The maximum and minimum, these are the highest or lowest value of y. So the vertex is called hk. The k is the y coordinate. It's the special y coordinate. And it'll be the maximum or minimum in a quadratic equation. It again occurs at the vertex. And finally, the domain and range. The domain is all the x values. We call that the input, or call those inputs. And then the range is going to be all the y values. Those are outputs. All right, so let's start identifying here. We have some equations. We want to classify them. Remember, the highest degree needs to be a 2. I see an x to the 2, nothing bigger. That's a quadratic equation. Here's another one with an x squared. It's not in the front, but that's okay. The highest is an x squared. Here's one that is a little deceptive. If we FOILed this out, we'd see an x squared in there, and that would be the highest exponent, so that'll be a quadratic. Here's one with an x to the 1, not x to the 2. That's a linear. Another one that's quadratic. It's got, if you FOILed out the x plus 3, you'd get an x squared. This one's fairly obvious. This one has an x squared, but it's not the highest. It's got the x to the 3rd. We'd call that a cubic, or degree 3. A little tricky on this one. We've got a 4 squared. But the x is not raised to the 2, so this one's not quadratic. And then last, 4x cubed, it's not an x squared, doesn't even have it, and its highest exponent is not x squared. So that one's not quadratic. And now we take a look at quadratics in table form. We're looking for what's called a constant second difference. And if you remember doing linear equations to find the slope or to determine if something was linear, we found out that it increased by a constant rate. Well, in this case, the first difference won't be a constant, but the second will. So if we look and verify on the left, increasing by 1, there's a constant difference on the left, plus 1. On the right, if we did 12 minus 7, we'd get 5. 19 minus 7, or 12, sorry, is 7. 28 minus 19, 9. 39 minus 28 is 11. Okay, so this is definitely not linear. You don't have a constant. But if I do 7 minus 2, and 9 minus 7, and 11 minus 9, I do get a constant. This one we would call quadratic. Come over to this one, verify the left side. It looks like it's increasing by 1. And then we look here, we do 2 minus 5. That's going to be a negative 3. 1 minus 2 is negative 1. 2 minus 1 is 1. 5 minus 2 3. These look kind of tough here, but if we look at our second difference, negative 1 minus a negative, that's plus. So negative 1 plus 3 is 2. 1 minus negative, or 1 plus 1, 2. 3 minus 1, 2. This one is quadratic. This one is increasing by 2, it looks like, so we have a constant rate of change. 1 minus 2 is negative 1. 0 minus 1, negative 1. 1 minus 0 is 1. 2 minus 1 is 1. These changes, negative 1 plus 1 is 0. 1 minus negative, so that's 1 plus 1 is a 2. And then I get another 0. Find the following for the graphs below. So here we're going to, and we've gotten some experience with when we did the transformation section. The vertex here, the x-coordinate, looks like it's negative 1, 2, 3. The y-coordinate is 2. So negative 3, 2. And to find the max or min at the vertex, it is a minimum, and it occurs when x is negative 3, but the y value is what we care about when y is 2. The domain, as we talk about domain, we'll find that all reals, which is the same as saying from negative infinity all the way up to positive infinity, can be input to this graph or into the function. So all real numbers, there's nothing we can't put in to the function. And for the output then, the range, y is going to be greater than or equal to the minimum. If this were a max, we'd say less than or equal. Okay, so you can put both definitions for the domain. We're going to pretty much use this symbol for all real values, and then that'll be set. It doesn't change for quadratics. Vertex, we go over or left 5, 1, 2, 3, 4, 5, down 3, negative 5, comma 3, negative 3, sorry. And it is a maximum in this case because the graph goes up till it gets to y equals negative 3, and then it drops back down to more negatives. So y equals negative 3 is the max. The domain, again, all reals. This will not change. The range is going to be y is less than or equal to this maximum, negative 3. Why don't you try this one on your own and then hit play after you've made your best guess. Okay, the vertex, the x-coordinate is 0. The y goes up to 6, it looks like. It is a maximum because this parabola opens down, so it increases. The y value increases until it gets to 6. Then after that, it descends, comes down. Domain, all real. The range, because it's a max, it's going to be all values less than or equal to the maximum of 6. All right. We're almost done here for a quadratic equation in the form y equals ax squared plus bx plus c. If a is less than 1, this is something to take note of. When a is negative, we would say a is less than 1. The graph, the parabola, is going to open down. That means the vertex is going to be at the top and the arrows will point down to negative infinity. If, on the other hand, the a is positive, if a is greater than 0, the parabola that you could graph would open up. Lastly, if a equals 0, we have a different problem. It's not even a quadratic. So a must not equal 0. Otherwise, it won't be a quadratic. We have to have an x squared. With a coefficient of 0, we wouldn't even have our x squared. If this parabola opens down, that means it's an upside down u. You'll have a maximum. Likewise, if it opens up, meaning it looks like a u, you'll have a minimum value down at the vertex. The domain is always all real values. And then the range is simply going to be y less than or equal to k. As you recall, a vertex can be written as h comma k. The k is the y value. So if it opens down, k is as high as it gets, and then it comes back down. Likewise, the range is going to be greater than or equal to k. Y is going to be greater than or equal to k if it opens up. All right, with that, give you a chance to work on your own, and we'll see you in class.